All right, how do we find the kth term in a binomial expansion? Well, generally, the general term or the kth term in an expansion, for instance, if you have x plus y raised to power n, when you are asked to find the kth term, for instance, the seventh term, the eighth term, the fifth term, and on, if you're told to find the kth term, what you have to do is to go on to use this formula. You'll be having n combination k minus 1 x, that's the first variable, raised to power n minus k minus 1, then y raised to the power of k minus 1. So generally, as you can observe, if you had a binomial expansion of this form and you were told to expand it, what you would normally do was going to go on using the general formula for a general binomial expansion, which was this: n minus k, then y raised to power k. So this was that for when you were just solving a binomial expansion from scratch. But when you want to find a particular term, what you use is what we have here. So you don't use this. What you just have to do is go on to, if you are told to find the seventh term, that means your k there was 7, you'll be finding the sixth, your k will be 6. Like you'll be using the value, corresponding base value of the combination here as 6 rather. So if I wanted to find the seventh term, that means I'll be solving this place as 7 minus 1, which will be 6. So it goes on to affect every aspect of the formula. So instead of having, so you'll be having n combination 6, x raised to power n minus 6, then y raised to power 6. So that's the general way of dealing with kth term. So let's take a quick question. For instance, you're given the expansion for x minus 3 raised to power 11. And you are told to find the seventh term. So we are told to find the seventh term. So what do we do here? Well, what we have to do is to go on to apply this formula. Our k here is 7 because we are finding the seventh term. So what the next thing to do is to go on to say the n here is 11. That will be 11 combination. Now k minus 1. Our k is 7. That will be 7 minus 1. Then our x here is x raised to the power of 11 minus 7 minus 1. And then you have minus 3, which was the other term, as 7 minus 1. So this is what you will solve to get your final result. So looking at this, you will be having our seventh term to be equals to 11 combination 6, x raised to power 11 minus 6, then minus 3 raised to power 6. 11 combination 6 gives you a value of 462. So you have 462 x raised to power 5 minus 3 raised to power 6 gives you a value of 729. 729. The minus, of course, when you have an even power, the minus is cancelled out. So 462 times 729 gives you a value of 336798. X raised to power 5. Now we can see how easy it is to find a particular term in a binomial expansion. Now, the other tedious way you could have gone, the route you could have taken, would have been to expand this whole term, the whole expansion. That means you find all of the terms, and then go on to count them to the seventh term, which would take a whole lot of your time. But this particular way is a very simple trick in solving these questions. So let's see some other examples. All right, look at this question we have. We're told to find the fourth and 10th term in the expansion of 3x minus 2 raised to the power 10. Now, a very tedious way for someone not knowledgeable about this particular solution will be to go on to expand the whole term. That means you go on to find the whole 11th term. Don't forget, for a binomial expansion, the number of terms will be n plus 1. So in this case, when you have raised to the power 10, you'll be having 11 terms. So you need to, if you were going to go through the long route, tedious route, you would open everything and then go on to count for the fourth term and then go on to the count for the 10th term. But with this particular trick and fast method, you don't need to do all that. All you need to do is just apply this particular formula. So for us to find the fourth term, all I need to do is to go on to say the fourth term will be equals to, my n here is 10, I'll be 10 combination. Now instead of having, my k here is 4, so I'm dealing with 4 minus 1, that will be 3. And then x, sorry, we don't have, our x here was 3x, because our first term here, this represents our first term, this is our second term. So we have 3x raised to the power of 10, that's n minus 4 minus 1. And then we have y, which represents our second term, which is minus 2 here, raised to the power of k minus 1, which is 4 minus 1. So we have 10 combination 3. Then we have 3x raised to the power 10 minus 3. Then minus 2 raised to the power 3. 10 combination 3 will give you 120. That'll be 120 times, this will be 3 raised to the power 7. Then x raised to the power 7. Then minus 3 raised to the power 3 will be minus 8. So if we go on to solve for 3 raised to the power 7, that gives you a value of 2187. So we'll be having 120 times 2187 times minus 8. Then x raised to the power 7. So what we can do, let me try and put the solution here, down here. So that will be 120 times 2187 times minus 8 times x raised to the power 7. Don't forget, we are trying to find the fourth term. If you do the multiplication of 120 plus 2 times 2187 times minus 8, you will get a value of 2020 minus 2099520. Then x raised to the power 7. So you can see that questions like this in an exam hall is not meant to be expanded fully. You can use this particular simple technique to go straight to your answer without having to spend much time. Let's try and find, you can pause the video and try and find the 10th term. So all I'm going to do here is to change this to finding the 10th term. So if I want to find the 10th term, my k here will be 10. I'm dealing with 10 minus 1. I'm dealing with 10 minus 1. I'm dealing with 10 minus 1. In this case, my k is 10. So obviously, this will change to minus 9. This will change to 1. And this will change to 9. And this will change to 9. So I can do my calculation with this premise now. That will be 10 combination 1 will give me a total value of 10. So that'll be 10 times 3 raised to power 1, because this will be 3 raised to power 10 minus 1 is minus 9 is 1. That'll be times 3 raised to power 1 times x raised to power 1 also, and times minus 2 raised to power 9 will give me a total value of minus 5 512. So minus 512. If you multiply minus 512 times 3 times 10, you get a value of minus 15360. Of course, x raised to power 1, which is still x. So can you see how easy and simple it is to solve the kth term of a binomial expansion without wasting time? So this is how you solve for the 7th term, the 10th term, or whatever number of term you were told to find. All you have to do is to apply this particular formula, and what the formula is similar to the original formula, but the difference is that wherever you had k before, you'll be using k minus 1. So you can see how everywhere we used to have k was substituted for k minus 1. Once you do that, you arrive at the exact term you were told to find. Alright guys, I really hope this video was helpful to you. I hope to see you in the next video. Bye bye.